Bismillahirrahmanirrahim. Today we discuss gradient of a scalar field. Gradient of a scalar field or a scalar function of several variables. The definition of gradient is given as if the partial derivative of f of x, y, z are defined at point p naught of x naught, y naught, z naught, then the gradient of f at point p naught is the vector del f equal to partial f over partial x I component plus partial f over partial y j partial f over partial z. Okay, here del is a vector operator partial over partial x, partial over partial y, partial over partial z, and f is a scalar function, and f is any scalar function whose partial derivatives are defined if f of x, y, z is equal to x cube minus x y square minus z, and p naught into 1, 1, 0, then partial f over partial x is equal to 3x square minus y square, partial f over partial y is equal to minus 2xy, and partial f over partial z is equal to minus 1. In case of partial derivatives, if we take partial derivative with respect to x, we consider y and z are as a constant, and if we take derivative with respect to y and we consider x and z as a constant, and if we take derivative with respect to z, then x and y will be constant, and we know that the derivative of constant is 0. So we have partial derivatives. Now we obtain these partial derivatives at a point p naught. Partial f over partial x at point p naught is equal to, here the value of x is 1, y is equal to 1, and z is 0. So we have 3 into 1 square minus 1 square is equal to 2. Partial f over partial y at point p naught is equal to minus 2 into 1 into 1 is equal to minus 2, and partial f over partial z at point p naught is equal to minus 1. You can write it as del f at point p naught is equal to 2i minus 2j and minus k.